So let me talk. This builds on what I was talking about 2 days ago, 2 evenings ago, I guess it was now. And this is more on capabilities. And what I want to do is I want to use this overhead, and then I want to switch back and forth with a couple of other overheads and try to, a couple of other handouts to try to explain a little more factual detail. But this is kind of the plan, what I really want to talk about. I want to talk about human capability formation. Before, I really talked about the structure of capabilities and how they map into things that we're interested in. And that concept of capabilities was one of expanding opportunity. And then I want to consider evidence on inequality in human development and talk about evidence not only from animal studies, but also human studies looking at critical and sensitive periods in human development. Then I want to talk a little bit, and this gets right into the study by James Best on genes, biological embedding of experience, and gene-environment interactions, what's called epigenetics. And then I want to talk about models for human capability formation. And people can interrupt or not interrupt, but ask questions and speed up and so forth. Then I want to talk about the estimates of the technology of skill formation, a lot of work that I've done with Flavio Cunha, and then discuss aspects of causality, which takes us back to a question I raised but didn't settle on Thursday night. And then heterogeneity, and I want to look at some other factors. So heterogeneity is just kind of the key word in this whole literature and capabilities. So I want to outline a framework for thinking about the dynamics of skill formation, and I want to make just 2 obvious points, which is there's a huge amount of literature, huge now, and it's been around probably from the beginning of time, but it's received a lot of interest in the last 20 or 30 years as we've gotten much deeper biological understanding and understanding of these relationships. That supportive family environments, measured in various ways, shape in part later life outcomes. And there's a lot of evidence on that point. The other part is that they're not the sole determinants, and that we have to think about this in a life cycle perspective. So the danger in all of this literature, there's a huge literature going out, people saying early years matter. They do, but later years matter as well. And a key component is how resilient people are. And then from the point of view of public policy, what interventions at what stage, what environments at what stage are most effective for shaping different types of capabilities. And you'll see a difference among these components. We've already talked about the third point and so forth. So these are the questions that are out in the literature. So I use the word investment in a very general way. It would include things like schooling, it would include parenting, it would include neighborhoods, it would include various support for individuals. So how important are investments in early years compared to later stage investments? So we actually have a whole we have a lot of empirical work in labor economics and other fields inside economics looking at the effectiveness of intervention at different ages and for different ability levels. And so the question is how important are investments in environments compared to later stage investments? So more generally, the question is how should we stage these environments? And this is not a trivial question. Because even today, and it certainly will show up in the political debates in virtually every country, there's an idea that we should really help the disadvantaged, and we should help them in various ways. So about 50 years ago, when Lyndon Johnson launched the War on Poverty, the idea was we could suddenly, we could sort of intervene at virtually all stages of the life cycle and it would make a difference. There was a notion that somehow people were very, very plastic, in the sense they could be molded in various ways, and even giving job training to 50, 60-year-old unskilled workers could promote them to full productivity. And we've learned a lot since that time, and I want to try to show you what a framework is for thinking about it. But the really important question, which shows up a lot, is resilience. Resilience is a theme that's been studied a lot by human development experts in psychology in particular, but also in just child development, I guess, more generally. And the question is one of resilience. And the reason why this is important is that you want to really separate out this notion that somehow a bad environment sets the stage for the rest of your life. It's just not true. So in Chicago, until fairly recently, we had a concentrated area of poverty that was notorious for having gangs, for having all kinds of difficult situations for people living in them, and it was alleged to be and it was, I think, quite a challenging environment to grow up in. And so when you looked at the kids who came out of those environments, you found that on average they were somewhat at a disadvantage compared to others. But there was also an amazing amount of resilience that a lot of these people, even the story I like to give is a story that's even not even related particularly to human development, but about 80 years ago, that everybody used to have a watch that glowed in the dark. And the reason it glowed in the dark was you painted, it was at radium. It had radioactivity. People were very naive about radioactivity. And there was a group of painters, people who actually worked in New Jersey, it turned out, painting radium onto dials of watches so they would glow in the dark. And the claim was that they had ingested over their lifetimes radioactivity of a level of like being exposed to 100 Hiroshimas, just an enormous amount of radioactivity. Now, how many of those people died of cancer? You'd think everybody. This is truly atrocious. No, about 20%, 25%. There was a lot of resilience in biological and social, I mean, in this case, just purely biological resistance, the ability to do so. You have lifetime smokers who, they live to be 115, not 115 maybe, but 100, and you can see a lot of, so there really is a sense of both biological resilience and social resilience. And that's really the key question. When you have early disadvantage, how important is it? And so it's really important to adopt a life cycle perspective. We have a lot of studies saying if you're in the womb when a time when your mother is starving, that has consequences for lifetime outcomes, and it does. But is that the whole story? And how important part of the whole story is it? And exactly what the mechanisms are. So I want to look at resilience. And then closely related is the question of later life compensation. So this is a question. So you're economists, mostly, and as an economic standpoint, suppose that we can say I can make an investment when somebody is 20, and I can make another investment when people are 0. The cost is the same in the sense of real resources devoted to it. But I'm a planner, a government planner, say, and I can tell you if I can delay this investment to age 20, then I can basically harvest the rate of return and the alternative opportunity cost of funds, have more to invest at age 20 than I do at age 0. And therefore, there's always a notion that if two investments are equally productive in producing adult outcomes, then they will be, it's always better to delay. So the question is, do we really need to worry much about early life and later life? So that's part of what I want to talk about. And then I want to talk about this measurement issue, although I talked a lot about that on Thursday night. And what are the effective policies? So the crucial notion of this work, and I think it's very important to go beyond just kind of saying, here is a treatment effect, or here's a correlation, and then here we have a treatment effect, to really understand the mechanisms of family influence, exactly what the family does, how the family and the environment generally promotes these capabilities. And so we want to look at genetic mechanisms, parental investments, and then epigenetics. I don't know how many of you heard about epigenetics, but epigenetics is basically this effect of how the environment affects expression of the gene, and I'll show you some examples of that. And then we want to look at the interactions of family with environments. A very important question is going to be, how well do parents support the children in the school? If I enrich the school, if I enrich some environment outside for the family, do I actually find that this produces a substitution on the family side, or does the family work harder and actually reinforce what's given? So that's the complementary substitution issue, which is actually quite important. I mean, at one stage, Becker, writing some 40 years ago, was arguing substitution was the rule. It turned out that Head Start at the time was considered not to have been very effective, and it turned out, I mean, one of his notions at the time was, well, parents are recognizing their children get this enriched environment in Head Start, so they substitute. And so that could undo the effect, or maybe they divert resources to the other child, in which case then the effect could be considerably weakened. On the other hand, if there's complementarity, it would be strengthened. And then there's this other question about interactions of family with environments, credit markets and financing of skills, which Lance Lochner talked about, neighborhood effects, peer effects, and parental influence, which is what Steve talked about earlier today, and then this notion of parental support in schools. We already talked about these multiple capabilities, so I'm not going to talk more about them. I'm just going to base on it. What I am going to add is biology and health. I'm going to talk about the interaction among these three different types of capabilities, and each of those is a vector. And I want to understand the dynamics of life cycle skill acquisition and the synergies in producing capabilities, and exactly what we know about it empirically. And then I want to integrate the study of interventions with the studies of family influence. I mean, you'll see out in the literature a huge number of treatment effects. People say this program works, that program works, but exactly the mechanism by which the program works is not clearly specified. And this framework gives us a way, I think, of putting that together. So exactly how do we place interventions on the same footing as family influence studies? Typically, these are treated as separate issues. It's a mistake, but even data sets are organized around the notion that you somehow should look at family influence, mother's education, how much time she spends with the child, and so forth and so on. And then interventions like Head Start or preschool. And these two really are intervening in the same way. They're both changing the capabilities of children. And in fact, the interaction between the parent and the intervention is really quite important. So only recently have we made progress in that regard. So I want to evaluate the effects of a lot of interventions made at various stages in the life cycle. I want to look at experiments with long-term follow-up. I want to look at longitudinal designs. And I really want to emphasize that even though there's, out there you probably heard the slogan that randomization is the gold standard. It's not. It really isn't. It's not just because randomization gets compromised. It almost always does. It's that social experiments generally are looking at mean differences. And actually, we're usually interested, especially in this kind of class, at distributions of outcomes. And really, if you think about it for a second, only under special cases, which unfortunately are dominant in the literature, but only because of convenience, can we actually recover the joint distribution of treatment effects. And some of these longitudinal methods actually allow us to do that. You probably talked about that today a bit, didn't you? Yeah, no, I'm not saying nasty things. I'm just saying that there's an additional, these things are complements. Somehow people get into the mindset that, there's a gold standard or something of the sort. So this is a key point, and it's nice that Seung Moon is here because he's done a lot of good work on this question. But you recognize that various interventions really, when you compare different kinds of programs and different kinds of interventions that are just strictly interventions, that they really differ because the populations they target are different, the objectives and philosophies of the programs differ, and the measurement systems are different. So it's like literally we have these programs. I'll give you an example. The preschool study, which I'm going to talk about, is basically targeting kids who had low IQ when they're 3 to 4 years of age. That was the enrollment. That was the criterion. That's how the money actually was funded for the program. Now, the ABC program, which is similar in spirit, although it's much more intensive, it lasts much longer period of time, so the programs that really aren't really the same, and it has fewer, at least in the early years, fewer parental visits. The ABC program enrolled children into the program based on conditions of the parents, because they were trying to get kids at birth. Well, they couldn't measure the IQ of the kid, and so by any matter of regression to the mean, you typically found an above average population. So you chose low IQ as the criterion for enrollment into the Perry program. In the other program, the ABC program, the average IQ was about 15 points higher at enrollment. And that was just because the population of the parents' characteristics of the sample, not the population of the kid. That's a regression to the mean of the population. So, and again, the methods of evaluation differ. Some are experiments, some are non-experimental evaluations, and there's a lot of difference. And so the goal here is to try to think of a framework to integrate studies of family influence with the intervention studies. And then, and key is when we think about these policies, it's very nice to know that early years have an effect, but we need to compare alternative policies in comparable metrics. Rates of return, cost benefit is one way, and I want to actually talk about whether or not these different metrics are necessarily at odds with each other and what the evidence is. So I want to try to think of just a common framework for thinking about this, looking at mechanisms and going beyond what some of you have probably seen, so-called meta-analyses. I mean, somehow there's out there in the literature this notion that somehow we can aggregate all these very diverse studies by putting a p-value and saying we're going to aggregate these p-values. You've probably all seen some version of this, meta-analysis. Everybody seen this? Nobody's seen it? Okay. What's the problem with the way it's actually used in practice? Well, the way it's actually used in practice is, I mean, meta-analysis is an ideal study, an ideal approach. If somehow we had this following artificial situation. We had like 1,000 different laboratories all running the same experiment with the same subjects. And instead of somehow being able to, and so with the same measurements, everything is identical, but some moron has taken those data and thrown them all away, and the only thing we have from each of those 1,000 experiments is a p-value. And then you aggregate up those p-values in these meta-analytic standards, and you can come up with an overall statement. It's the second best. It'd be better to go back and pool the data. But in fact, these studies differ tremendously. They differ for all the reasons I said before. And so when I do a meta-analysis, you know, some people say I can regress the p-value on some x's. Maybe, but it's really not the same. So there really is a sense in which these studies certainly should be taken not just as meta-analyses, but as structure of on their own merits, looking at these points about 0.6 here. Okay. So, so the point is longitudinal data are extremely valuable and so forth. So I want to take about a framework for analyzing human development that emphasizes the theme that I made last time, that integrates the study of family and literature and accounts for multiple channels of influence. So what do we know? So let me just review the studies and I'll show some evidence. I'll show some evidence. There's a lot of it, and I put up a bunch of posted a bunch of handouts that give you some evidence for what I'm saying. So I'll give you the rudiments of this, and if there's more interest, I can actually can go into greater detail. So there's a core low-dimensional set of capabilities. That's the notion here. And this actually gained, to me, salience even more in the last couple of days when we looked at a very high-dimensional factor analysis, looking at what essentially is a statistical way to implement these capabilities, and finding that the low-dimensional representations do an extremely good job in representing outcomes and explaining a variety of things. And therefore, you know, any notion of science really has to think about fairly low-dimensional sets. We already went through this, and I'm not going to repeat it, but I'm going to draw on it, that if we look at a lot of outcomes, that both these cognitive and non-cognitive capabilities are important, and some of the biological components associated with health are important. The capabilities, though, are not set in stone, and that's the point of this lecture, how things actually emerge, how they develop. And what we've learned from a lot of studies, animal studies and so forth, is that critical and sensitive periods exist. A critical period, I'll define it precisely in a minute, but kind of intuitively, that if you imagine that there's a target of opportunity just for that capability to emerge, if you don't hit that target, you won't get any outcome. You just won't. There are extreme examples of that. The one that's often given in this literature, it's a biological example, is basically the structure of vision. That you actually find that if children grow up in environments where vitamin A is deficient, they can be blind, and they can stay blind. There's no way to solve that problem. But if you essentially give the kids one little drop of vitamin A, that can lead to permanent sight. So that's an extreme case. And if you give them the vitamin A at age 5, it's too late, at least by anything we know. And the same thing is true about removing cataracts on the eye. Now, very few things are so stark, but I'll show you some examples that are pretty stark that suggest that for certain capabilities, namely cognitive ones, they tend to be somewhat earlier, at least sensitive periods, where the marginal product holding all other inputs constant are higher. And we find that later, that for non-cognitive capabilities, we actually see more flexibility later on. I mentioned that Thursday night. And also for health, it's not so clear about critical and sensitive periods. Somebody can stop smoking at age 40, and if they stop smoking for 10 years, they're virtually the same in terms of their health capacity. So what you'll actually see is there tends to be a lot more malleability in many others. Now, obviously, you cut your arm off, that's going to be pretty hard to restore, at least under current technologies. So there will be certain aspects. But with health, ALS is known, but what is known suggests more malleability. Now, one thing that's extremely important, I think, in this whole literature is that the gaps across social, because we're talking about social inequality, that the gaps across socioeconomic groups open up very, very early. And I'll show you some graphs that are quite revealing. These gaps are persisting very strongly for cognitive capabilities. So coming back to the critical and sensitive period, it seems like the years before teenage years, certainly maybe before 10 or 11 even, are very important for developing cognitive capabilities. Some of the early interventions on disadvantaged children have been shown to permanently boost IQ. They last. It lasts until at least 21. I don't know, is it true now, Seung? Does it go to age 30? It lasts. Okay, he's the expert, so you can ask him on this. But it is. For non-cognitive capabilities, there's less of a persistence. So if you look at the rank orders, you can actually see that even into the later life, and I'll show you some evidence on that. It was actually at the end of my previous lecture. It persists strongly, less strongly for non-cognitive capabilities, and that's partly with what people are thinking as the development of the prefrontal cortex and the decision system. So we think that children, even late adolescent lives will make mistakes, and you will actually see mistakes. I mean, insurance is written on this principle, right? I mean, you can't rent a car. A male can't rent a car until he's 25 without, putting up a lot of strong bonds and so forth. So there really is a sense in which we think that there really is a development of these certain matters of judgment and so forth. And so we can actually see the gaps are opening up. What we actually can see is that some of the gaps in biological capabilities, for whatever reason, we have to go back, they seem to be widening. And I'll show you some examples of those gaps. Okay. So what do we learn is that some early childhood interventions, even though I mentioned one where this isn't true, a lot of them seem to be primarily operating through non-cognitive skills. That is certainly true for Perry, and it's certainly true for a lot of these interventions. And that's important because it then affects the way we measure the success or failure. When Becker was writing the paper I mentioned earlier, everybody was judging whether Head Start worked, whether or not it raised IQ. It didn't. Everybody said it was a failure. And that was exactly a failure of logic, because what people didn't realize at the time, and that was the heyday of cognitive psychology, and people thought that the be-all and end-all of the human being was IQ or some measure of intelligence. It turned out that even though Perry doesn't raise IQ, it raised in a number of dimensions non-cognitive capabilities and has a very high benefit-cost ratio. So it is actually a very effective strategy. What we've come to learn is that because of this knowledge, adolescent cognitive remediations are largely ineffective, at least as they're currently implemented. And I want to talk about a framework that puts these things together. So let me get back to this thing that I put up actually the first day, the very first lecture. This is the concept of capabilities. James Foster has worked a lot on this as well, as I learned over the course of this week. So you want to think of this capability vector theta t as having subvectors of possibly very high dimension. Cognition, non-cognitive. I showed you the different dimensions of cognitive, at least fluid and crystallized. Non-cognitive has many components, the big five we talked about, and different aspects of health that would be realized. And so this is kind of the framework that I want to think about. And any framework of this type has four components. So the outcome functions is what we talked about Thursday night. Dynamic technologies for producing the capabilities, what I want to talk about today. But in a model of investment, we need to think about parental preferences, really group preferences, shaping the investment. How much stimulation is actually applied, and what are the preferences? How altruistic are the children, are the parents of the children, or the environment of the children? And then very much mirroring what Lance Lochner was talking about a few days ago, looking at constraints. So access to credit markets, time constraints, and constraints from social interaction. So a complete model would have all four components. And unfortunately, there is no complete model right now. There are a bunch of sketches of models. And I'll try to describe those models. But these are the four natural components. So here's the framework. So what we want to think about is the following. we have an outcome, yjt. And we have this psi j, which depends on the cognitive and this measure of effort. This I introduced Thursday night. Okay, and effort can depend on incentives and endowments as well. Okay, and so rewards captured by rjt. What I want to consider, though, and we didn't consider before, is the technology of what we call capability formation. So this is stated in recursive form. You could do more general technologies, but this is quite useful, I think, as it stands. And so what we want to think of is that instead of the notion that capabilities are just fixed at birth or are fixed genetically, they can be a function of, let me use the pointer, they can be a function of not only the stock of previous investment, you could just think of this as a depreciation model, the amount of investment, and then some parental environmental variables. Think of this as parental or social public goods. And that's actually what's producing it. So the key notion I'm going to focus on is this argument here, and then how much this carries over. I mean, if this good were just completely depreciated each period, there was no persistence of capability, you'd be left with this tremendous, basically you'd be starting over again each period. And what we see is a lot of persistence, and if anything, persistence is growing, but it's far from perfect persistence. Investment changes. So we know that even neurogenesis, the production of new neurons, continues to people into their 80s and 90s. It's even been found in very ill cancer patients. So we actually see that these capabilities, at least as associated with neural development, are actually being produced throughout the lifetime. We use the standard notation about theta naught as the initial endowment. Genes would show up as part of the initial endowment, the way I put it. But the environment could modify those genes. And so the environment would be both theta PT and investment. I'll give you an example of that in a minute, where genes are actually modifying the environment. Now the key idea, though, in this literature is one of complementarity. We call dynamic complementarity. And it's really very simple. So you don't need any derivatives, but I'm going to make it for some simplicity. The idea is that basically the investments tend to be more productive the higher the stock of skills. Now, many people will say, well, maybe that's not true, that you get jaded. That could be. But suppose, but in fact, a lot of evidence points in that direction, and that notion can explain a lot of evidence. So what we see then is complementarity in two senses here. One is static complementarity, and that's a standard notion that literally the higher theta t, the higher the productivity of investment. So if you're smart, it's even better to invest in you. You're energetic, you're smart. And in fact, this helps to explain a lot of data. I can show you some rates of return. If we look at the rate of return to very smart, very highly motivated children going into the first years of college, you can get estimates of rates of return that are as high as 20–25% per annum. Very high return. And for kids who have very low levels of productivity, very low levels of theta, especially in the adolescent years, it actually suggests that there could be, that there actually are quite low returns. So this kind of static complementarity helps to explain some of the evidence I already referred to. But now you might say to yourself, wait, something's very strange here. Does this suggest then if you start bad, we just should throw you aside? You're part of the social debris. No, and that's the interesting part of it. There's dynamic complementarity. And I'll give you an example of it. I sketched a very simple example, and I'll maybe if I get through the paper with Flavio, that I can give you the very simple intuition. But the idea of dynamic complementarity is that basically, remember how productivity gets shaped. Go back to this technology, this very simple technology, this equation 3. I can improve the initial positions of people at any period by making investments. So it doesn't follow just because there's static complementarity or even dynamic complementarity, which I'm needed to now define, is that basically what I'm getting is, yeah, you can generate complementarity between investment in period T and investment in later periods. So by investing now, I make later period investments more productive. So if I think of this as a life cycle decision problem, instead of just thinking about it as a simple static problem, which could lead to a kind of social Darwinism, right? The low theta naught people, should be put in reservations. That's more or less, by the way, what Murray and Herrnstein said in their book, right? I don't know how many people read the bell curve. The bell curve suggested you have these cognitively feeble people, and what we should do with those people is basically put them on reservations. They should be taken care of. We don't want to kill them, but we certainly can't expect much from them. That comes from a notion that somehow theta t is fixed in advance, and secondly, that there's nothing we can do to boost it, and third, that there's no complementarity. What I want to argue is a lot of the literature suggests just the opposite. There really is a lot of complementarity, and in fact, I can show you, it's not a theorem, but it's an empirical regularity, and I can show you a lot of evidence that supports it, that in fact, even though it looks like this complementarity leads to a kind of inequity, that if you think about what is socially efficient from the point of view of just maximizing output, never mind inequality, then you actually can find that you can improve equity. You can actually redistribute towards the more disadvantaged and at the same time boost productivity. And the mechanism is dynamic complementarity. So let me just spell out the mechanism and I'll motivate it, but I want to turn to some evidence first. So higher investment in period t raises theta t because the technology is increasing. That raises theta s because the technology is increasing in this investment for some tau between t and s. So by investing today, I make the child a more suitable object for investment in the future. That's the dynamics of what's going on. And that raises the marginal product later on and so forth. So what this helps to explain, this dynamic complementarity, is the evidence that early nurturing environments affect the ability of humans and animals to learn. And it also explains why investing in very disadvantaged kids can be very highly efficient, because you're building the stock. So I'll show you some evidence in econometric evidence. So it also helps to explain at the same time, though, why investment in low ability adolescents has such low return. So if you get to a very late stage in the life, when, say, productivity is starting to diminish, the theta may be much less malleable, so there'll be some restrictions on this equation of motion. And what you'll often find is that at very late ages, adolescent, so there's nothing inconsistent with saying investments later down in the life may not be very efficient, but investments early can be very efficient. It really depends on the curvature of that technology. So you can define critical and sensitive periods with this in a kind of obvious way. That's a critical period. If the marginal productivity is 0 for any other period than t star, then there's no point in investing in that. And sensitive periods, again, evaluating at the same arguments, would be those where the productivity is higher. Okay, so this we've seen already. And I'm gonna switch over in a minute. This I showed you already, just to remind you though, because education plays such a big role, that if we look at the probability of educational decisions, and we ask who graduates from secondary school, what we see, and this is from a recent paper, but it's consistent with a lot of other evidence, then we move up the distribution of the deciles of cognition. What we actually see is we moved up to somebody who is basically at the top of the cognitive distribution. It's virtually certain that person will graduate secondary school. That's true. And the same thing is true here of socio-emotional skills. Now, this is the joint distribution, and you can see there's actually a lot of nonlinearity. I've just extracted the marginal distributions from the joint, fixing it at the mean. So there are lots of these marginal distributions that I could have extracted because there's no independence, there's no linearity separating it. And you can get that from a whole range of behaviors: 4-year college degree, wages, smoking behavior, self-esteem. These are the same components. This is literally what I was talking about Thursday night, but I just want to use that as a building block. White-collar occupation, physical health, Perlin's mastery scale. That's sometimes taken as a measure. This actually is now treated as an outcome. How much you feel. You control your fate. And you can see that both cognitive and non-cognitive skills matter. And they have different weights, but there's a general curvature and so forth. You know, who goes on welfare? And then the question of trust. Just, again, something that Ernst Fair and his group have spent a lot of time, and Armin Falk. There's, you know, some dependence on these basic capabilities. So this is whether or not you go to jail. Again, you can see strong relationship, teenage pregnancy, and so forth. So what we've also learned, and this is just in the recent paper with myself, Humphreys, and Urzua, is that these measures are actually quite primarily, not solely, operating through schooling. Schooling is a major vehicle. Education is the conveyor. So we tend to think, well, maybe this replaces education. No, these are important factors for determining who gets educated, and education has an independent effect. I'll show you actually some studies. Now,
that's a question for you, Florida.
Sure.
Is there any work on complementary between theta P and theta?
Yes, I'll talk about that. Oh. Theta P, you mean parents or just environment and theta. Yeah. You mean, yeah, well, who knows? We're already late. But let me start with some of the base facts. And this, to me, I have literally, in one of the other slides, I have literally like 20 different studies that show the same thing. So this is not a selective reading of the literature. I mean, there are a lot of papers, and I don't want to bombard you with them all. But this is from some study by Brooks Gunn, and this is across a population. This isn't a particular ethnic group or anything of the sort. This is basically going across populations. And what it's doing is it's looking at a measure of cognition. And the first graph is basically something that it's showing. There are two things about this graph. The first thing is apparent here. If you look at age 3, at age 5, and age 18, what you're finding is that this measure of cognition for children whose mothers are college graduates, you know, it's hovering about 1 standard deviation around the mean. Okay? It's constant. You say, well, maybe that's just normalization. Maybe we just fixed it. So that by itself doesn't tell you anything, but it's kind of interesting. Now we get to something that's maybe a little more interesting. And if I get to something that looks at women who have some college, you can see this is now just conditioning on the mother's education. You can see such substantial differences just in parental environments, just parenting environment, which is a very simple measure. This isn't a time use measure. This is literally the structure of education. And you can see gaps that are opening up. And you can keep doing this across different socioeconomic statuses as measured by the mother's education. And you see two things, very sharp gaps, right, at age 18. And those are very determinative of who actually goes to college. Those are very powerful. That's one of the graphs I showed you earlier. It's the reason why I repeated it. But the other part is that a lot of those gaps now were there already. And you can get this in percentiles and whatever. So you don't have to worry about a particular norming here. Those gaps are there before the kids are entering school. And then what's interesting about it, and Steve Raudenbush has a whole series of these as well. And I mean, I've been actually very interested and pleased to see so many different studies that have shown virtually the same thing. So the schools are there, and there is some movement here in these graphs. And we know the schools are very unequal across these, but it's not this whole story. The schools aren't, to my mind, the main thinking. Now, I realize that's contrary to a line of reasoning that's out there that we should devote a lot of attention on the school. But I'm just saying we report this, that we see that the socioeconomic gaps don't seem to be widening or falling. And this is true for a number of other measures. In fact, I'll show you some other measures.
Nature or nurture?
This? Well, right now we don't know.
Okay.
We don't know, but I'll give you some genetic evidence that some evidence that will really suggest that it's not all just genes. But right now, this is perfectly consistent with the genetic interpretation. See, if I'm really a social Darwinist, I can say, see, smart mothers, smart kids, dumb mothers, dumb kids, all heritable, and there's nothing that this figure says that rules out either explanation, whether it's just, you know, highly stimulating mothers or genetic explanation or some combination. But I will try to rule that out in a minute, because we can experimentally manipulate things like this and see effects where we then do basically hold the genetic material the same and expose people to different treatments, and we can see real effects, okay? But hold off, I haven't shown you that yet. Yes?
Are there any studies that look at the 0 to 3 thing?
Well, yeah, I can actually put up another slide if you want. I mean, well, I'll show you right now since you ask. I do have it. In fact, I have this figure that goes back to 0 to 3. Let's see if I can find it. I have to remember, what did I call it? See, this is an atrocious name, but fortunately, here we go. This is from a paper with Flavio, and let me just, if I can find it. Yes, That's the same figure. That goes back 0 to 3. Now, you ask, what does it mean to measure IQ of a kid at age 1? This is an old fallacy that's been out in the literature for more than 40 years. And in fact, the fallacy was most exposed by this guy, Lewis and McGurk, in Science magazine. This is looking at what are called Bailey scores as measures of cognition. Imagine giving a test of cognition to a 1-year-old or a 6-month-old. That's what the Bailey score is. There's allegedly a cognitive component that you can measure at quite an early age. But this has led to a lot of attention. So I put this here deliberately. I kept it off because it's a sign of a lot of bad science. But somebody put it out here and said, oh, look at the difference between blacks and whites, the gaps between the advantage and disadvantage. See, they start very early. They're all the same. And then suddenly by age 3, it opens up. That's environment. Well, yes and no, because this paper by McGurk and Lewis point out that the scores in the early measure of cognition, and that's really the measure of cognition here that's used in these early scores, that Bailey scores and the like for cognition at age 1 are really not on the same metric even for cognition, yes, as IQ and some of the other measures. You could even argue about 3. By 5, people seem to be, but go ahead, yes.
And I still do, I mean, even if you have, say, you would probably measure cognitive ability at that age, which you can, but even then, I mean, it doesn't necessarily say that the rest of the effect can be attributed to the environment, because maybe some genes, they just have an effect.
Correct. No, that's another thing, that the genes could be sitting there. Exactly. No, the notion could be, well, the genes are really sitting there latent, and they're not going to be expressed until they get the right environmental cue. And I'll show you that. I really will show you that on a slide here.
Do you have a similar graph of birth weight, like birth weight of kids by different levels of education?
No, I haven't. Sion, what do you know of looking at birth weight?
Yeah, birth weight of kids by education. So the same graph, but with
there's a gradient for sure. And birth weight is, but I mean, what would you look at in the sense that you get birth weight and then you would ask for obesity at age? It's certainly a predictor. I mean, if you're really big at age 1, you're typically going to be pretty big at age 10, but it's far from perfect.
I just would be interested to see what that looks like. I mean,
though there are sharp differences in birth weight across socioeconomic groups, but I'm not exactly sure what the metric would be.
An interesting data score, the very first IQ test most kids take is taken at 1 hour. It's called the APGAR test. Do they have data on that?
They do, but the problem is, again, you really want to call that an IQ test, though. A lot of it is just, you know, you ask the kid to respond. You sort of ask whether or not they're going to respond. I mean, that's where I think we have to be really careful of asking, is it really on a comparable metric, these different things. But you do have APGARs. That's not an APGAR up there. This is called a Bailey. This does start only at age 1, but there are APGARs that are given at age 0, essentially, just age 0 plus epsilon. I don't know. I haven't seen that. But Xiong, what do you know about this? I'll put him on the spot. No, in terms of the ABC data, we actually have, yeah, I mean, haven't looked at that. Do we know what the story is in terms of that? The gaps? We can follow these people out till age 30. What's that? Yeah, not a clear story. Okay. Let me see, by the way, these are some of the other graphs I was referring to. This is CNLSY. This is, by the way, PIAT math, where you actually do see some divergence. So this is a math score taken at age 6, going up to age 12. So there is some evidence here, but that's acquired learning. And that is an achievement test more than a straight measure of cognition. This is showing you what happens on these test scores if you adjust by, So for example, here are the PIAT math scores by race, okay? And then you adjust for measures of family background and so forth, and you actually find that these, if you look at maternal education, maternal AFQT, and broken home, you can get enormous compression in these gaps. So these are all just correlations now. There's nothing causal here. This is the same thing for non-cognitive skills, though. So you're starting at age 4, or only following this to age 12, you're finding that this goes to a substantial substantially changes the structure of, doesn't change. Here, a very high score is a bad thing. That's anti-social behavior. A very low score is a good thing. And again, when we look at measures of this time, it's family income quartile, you get something similar. These graphs are more or less interchangeable with mother's education, highest income quartile. And you can see once you standardize for those, just in a regression sense, you can compress these things together. What you make of it is another matter. You can say, well, no, still the genetic story is potentially alive and well in this story. This is, by the way, the Raudenbusch story I was telling you about. So yeah, the danger is I will go into hundreds of graphs, which I'm just doing. Okay. I will come back to this one because I need to try to discipline myself, although that's probably impossible. But let me try. This is where I left off here. So this is the graph. Okay. Did that? Somebody else had a question though. Did they get muted?
I just wanted to ask, how do we know that the ironing of the gap is not due to the reduction of the noise in the measure?
The reduction of the noise?
Yeah, so because they might be worried that at very early age, these competing measures have a very high noise to variance ratio.
Right.
And so probably that.
Oh, but you can standardize these. In other words, we can extract factors and so forth from these across children. So you can actually find, when you look at these, and there is measurement error, but you can correct for the measurement error. I showed last time I spoke the high level, the components of measurement error. But these scores can be corrected for that. And it's not the whole story. Yes?
Do you have something like this for kids who are adopted? Like, let's say, where you have data on the mother's education level, like the biological mother, and then you also have data on the, but then these kids were like adopted. So in a sense that they have the genes of the biological mother, but then they have the environment of the.
Well, I'll defer that till James Best talk at some key point, because that's exactly one of the studies that he's going to talk about. Exactly, right? So you basically, the trouble is always where the children, who adopted, what was the mechanism that assigned the children, right? And it turns out it's very rare that children from a very privileged category, even if they're adopted, will be put into extremely low quality environments. I mean, it could be like in times of war or plague or something, but generally speaking, there is an issue about how you assign. Let me put that to the side. There is some discussion. And what was the name of the book by Siegel? The Minnesota book? Born Together, Raised Apart. So you have these studies. It's literally a book that just came out a month ago. Here's the gap in health, and this is the gap in family income. So literally what you see is this is now a measure of the higher the score, the worse the health. So health status 1 is excellent, health status 5 is poor, and what we actually see then is that when we get out to high levels of family income, the gaps are really, I mean, if you go out here to children, say, who are in fairly low circumstances in terms of parental environment, you can actually see that there's a widening out of these gaps with age, right? So 0 to 3, 4 to 8, and so forth. So if anything, health seems to be widening. It's not got the same parallel structure. So here's the question. What role of families, this is the question Alonis was asking, which aspects of families are responsible for producing these gaps? Family environments and investments, social interactions, genes, and I want to try to summarize that evidence and then lay out a model. But first of all, let me show you some evidence. First of all, and this is what I put up the very first day, but just to remind you, that if we go over the whole US population, you get a comparable development for other populations, other countries around the world. But what you find is the very large component in which the children, if you go back to 1975 and you go up to 2010 where this graph ends, that the big growth component is children under 18 living with a single parent is cases where the mother is really never been married. Single parenting. That's been the huge growth, and that's across the whole population. So you can see that in the US population now, some close to 30% are living children are living in these families that are disadvantaged. But the big growth factor hasn't been so much in divorced or widowed. Widowed is really the shrinking, if anything, but it's really in the children under 18. Now, why is that potentially interesting? And again, I'm going to draw on some of Seung's work, and he's done a lot of work on this sort. But if you can measure year by year the level of parental investment, the material resources given to children by educational status of the mother, and how that changes over time. You see enormous differences between the more advantaged and the less advantaged. Here it's just more than high school. That's an even cruder cut than I had before. If you look at measures of cognitive stimulation, you see huge gaps. And those huge gaps, again, by parental background. If you look at cognitive stimulation, and you see, again, intact family, broken blended family, and never married single mother family, you can see substantial differences associated with just measures of direct parental investment. And I'm going to show you that those have direct effects, I would argue causal effects on this. Okay, so what do we know about critical and sensitive periods? I already talked about cataracts, vitamin deficiencies, and the like. Probably the most popular hypothesis is the one due to Barker. Doug Allman has been beating the drum on that, in particular Janet Curry as well. Field origins of the Barker hypothesis have suggested strongly that, and more recently work by Gluckman and Hansen, they have a book called The Fetal Matrix, a series of articles. They're really the successors to Barker. Well, Hansen is really the successor to Barker at Southampton in England. And what they found is the structure that they even have a model in which the fetus is actually anticipating the world in which it's being born. So it's kind of like I'd say it's an adaptive expectations model. The placenta is providing signals about whether or not it's going to be a good world out there or a bad world, and the child develops. That's the Gluckman and Hansen story. Without even that element of speculation, we know that things like fetal alcohol, the famous study of the Dutch hunger winter, there's a physician at Columbia and also in Holland talking about a famous period in the 1940s when there was a famine in northern Holland that was engineered by the war. One side was a little less, there was an uprising against one side, and they basically starved the population. And the children who were in the womb at the time of the starvation can be followed through their whole lifetime. They're now in their late 60s, early 70s, or late 60s, I guess. This was 1944. And they actually end up with substantially lower wages, lower measures of intelligence, achievement, and other measures of accomplishment. And there are similar studies by Meany and Ziff and Francis Champagne at Columbia, where if you starve the nutrients to the mother when the child, or the rat or whatever, Meany and Ziff are dealing with rats, you actually will lead to substantial lifetime changes. But you have to be very careful, and this is where I want to come back to this diagram repeatedly. That here, I probably should unfold it, but in the interest of time, I'll unfold it in one fell swoop. That we really are interested in this technology of skill formation is trying to understand the structure of how at each stage in the life cycle, prenatal, birth, early childhood, late childhood, and then adulthood, how the initial conditions, the investment behavior triggered by the initial conditions and what other signals there are, affect then the evolution of the stock of capabilities over the whole life cycle. And see, that's where the resilience and remediation issue comes in. So you could have a huge initial condition, negative shock, but if it can be undone through investment, remediation, what's the cost? And what we really need to do before we jump on the bandwagon and say, oh, it's early life conditions, how much of the early life conditions were also followed up by adverse later life conditions, even in the Southampton study. So it's a question then, how much really is early? How much, and again, what is the relative strength of this, of these associations? How productive is investment over the whole life cycle? And most of these studies, very few of these early life studies have control for later life conditions. So even in the Dutch hunger winter, there aren't really good measures. You see these kids who are born into deprivation. The same thing is true for those children born during the great leap forward, during the great starvation in China in the early 60s. You can see substantial life cycle effects. But you wonder exactly what was the nature of compensation that those children experienced when they were 5, 6, 8, 10, and whether or not there would have been more effective remediation. You know, exactly how was this followed up? And very rarely do these studies control for the later life evolution of these factors, and that's really important. Okay, so I should put up one graph on critical and sensitive periods. Since I'm floating now, I might as well continue to float here, and I'll go back to get 5, and this will be interesting. I'll start getting, eventually you'll get to all of these. Oh wait, that's not what I had in mind here. This is one evidence on critical and sensitive periods. You've probably seen this before. But again, in language learning, which is an interesting subject all by itself, there's, again, some neural evidence that's been assembled by a lady called Southport, I think is her name, where actually she did some studies of immigrant children who arrived in the United States at various ages. It's been documented that learning a second language takes place different parts of the brain. So between the ages of sort of, this should be 8 to 11, but in this region here, one part of the brain, a second language is acquired through a different set of processes. You literally see a different aspect of different parts of the brain being used than it is when you learn a language later. And so what you can actually see is the effectiveness in the language. So kids who start learning after about 11 or 12 will typically find it much harder, and adults are acquiring it much harder yet. So it's not that they can't speak English so well, but generally unaccented English, language acquisition. There are a lot of studies of that sort suggesting that, that there are, and this, by the way, is the kind of return that I was suggesting. If you look at kids at the distribution of the 95th percentile, and you look at the very able kids, those are the 95th percentile versus the 5th percentile, you can still see substantial returns to college, very high returns early on. That was the point. But I better get back on target or I'm never going to finish here. So that's more further evidence of critical and sensitive periods and complementarity. But let me get back to this thing here. So here, okay, oops. Oh boy, oh I see, sorry.
Jim,
Okay.
How does one distinguish between critical periods and complementary? What's the econometric identification of what's one distinguish?
Critical period?
Distinguish between critical periods and complementary.
Well, I guess you could think of it as, what I was thinking was, again, let's take a case where we're looking at a differentiable production function, okay? So literally, the way that I defined the critical period was basically one where the derivative was absolutely 0. And that would be evaluating at all levels of capabilities and the like. So in that sense, I could still imagine now, obviously though, at that point here, there would be no complementarity, right? That's the point. So that's your point. So at that point of singularity in the function where basically I'm getting no derivative, the cross partial should if it's identically 0, then I would guess I would get an identical, right?
Yeah, I mean, the question really had to do, it seems to me that the parity that the studies also suggest that there's a market of chaos, regardless of what happens later, are quite high, because presumably these kids weren't receiving much investment at that lesson.
Well, be careful. No. Well, no, because actually, and see, actually going back to the Perry study, what happened was that part of the Perry study, right, Seung, was basically parental visits. So what happened was that you put in place, there was not only just an intervention in the child, it was an intervention in the environment of the child. So given that the parent was around long after the experiment stopped, that led to some further enhancement, okay? Right, and actually with the ABC study, we can look at this question of how much the parental investment matters, how much investment in the parent follows, because we have actually different study groups where some groups actually receive parental training, like the baby college that we're talking about Thursday night, and others didn't, and therefore we can actually get an idea of how important that additional stimulation is. But I agree with you, as a technical matter, it's so basically that's what. So let me consider the evidence on genes. I'm not going to ever get to the model here, but I just want to lay out some of the. There's lots of evidence on this. It's very exciting. Now this is an emerging literature on the embedding of experience in the biology of organisms. And here we have much better evidence for animals than we do for people, because we can experiment with animals. But I'll talk about the study. So what we've learned is that there are environmental effects on gene expression. And again, when you go to the traditional models of gene-environment interactions, we typically find strong heritabilities. But we have to be very careful here, and let me explain why. This is the ideal for many twin studies. Everybody's heard monozygotic twins, the ideal, right? We control for the genetic similarities of individuals, okay? Now, everybody who's taken the first course in genetics will know that genes do nothing by themselves. Genes basically are turned on or turned off. They manufacture proteins, but the gene themselves, genes do nothing by themselves. The expression of the gene is everything. So the gene matters for sure, but just like you were saying, somebody was saying, that literally until these things get turned on or turned off, they're really no good. They're not going to do much for you. You can have this mass of genes, right, sitting there but unused. What this is actually a measure, and actually this is now actually getting close to what Bert was talking about just in terms of the physical, in terms of the chemistry of this, but I'm not going to get into that for many reasons. But what these are is basically what are called methylation patterns in the DNA of identical twins. These are identical twins. They're monozygotic twins. And this is showing the differential expression. Now, these are 3-year-old twins. These aren't the same people. These are 50-year-old twins. The only thing I really want you to take out of this picture is the differential coloration pattern. The genes, even though they're identical, have been turned on and off in different ways. That's what the heat map is. I'm going to show you some data from monkeys. The environment, something happened here that wasn't just purely genetic. So when you say, oh, I'm holding constant the genetic material, well, yes, you are, but you can see that the effective genetic material, which is the way the gene expresses itself, how the RNA turns on the DNA, that is now changed dramatically. Look at the 50-year-olds. These people went through life. So again, I mean, I wonder what Siegel would say, or for that matter, who's your friend at George Mason? The guy you admire deeply. I'm sorry, it's late in the day. I have to tease him, I'm sorry. But anyway, you can see the substantial differences.
I was going to say, aren't you the one who introduced me at the same time you introduced me to your friend Rick Sanborn?
My personal friend, okay, well. Now, what I'm saying, so you can see here substantial differences. And it's these expressions that actually turn on, that create immune systems, that create the development of protein, that actually show how human beings. So this is called DNA methylation and histone acetylation. So this already shows you experience gets under the skin. Here's an example which I think is very striking. Terry Moffat, a psychologist at the University at Duke University, actually has a study from a town, a village or town, I guess, a city in New Zealand, Dunedin. It's a cohort of children who are now in their mid-30s. It's a long longitudinal study. They've done very, very extensive studies. It's very secretive, so don't get your hopes up you'll ever get it, access to it until they've completely milked it. But what they do is they actually can look at measures of childhood maltreatment, not only observed externally, observed through police records and so forth, but also through observations of the family. So you get some idea of, and this is some idea of child maltreatment. Why do I go on about child maltreatment? Because one of the early findings, and this is what I talked about Thursday a little bit, but this is showing you the vivid evidence. And this is with her husband here, Casby, in the 2002 study. What they found was that, and it earlier reported, was that a certain allele of a gene, the so-called MAOA genotype, was highly correlated with crime. So if you had the sort of short allele, you're much more likely to be a crook and or being put in jail, or in this case, it's male conduct disorder, which is highly predictive of adult criminal behavior. And so that led to this whole notion that there was a genetic basis for criminality. And people have put forward that view. Herrnstein and Murray, Murray and Wilson, Herrnstein and Wilson actually had that idea. But what was interesting was the following. when you actually ask, when did the gene show some expression? Here you can see kids who are from relatively advantaged environments. And you'll notice there isn't a lot of difference in terms of adult conduct or conduct disorder between those with the gene and those without the gene, the low and the high levels, okay? A little bit of a difference here with mild maltreatment. Where it all came out was the gene expression through environmental stimulation, negative stimulation in this case. So what you saw was that what looked like a genetic proclivity was actually turned on only by the gene nested in the particular environment. And this has been, there are 8 replications, 6 actually support it, 2 failed to replicate, and there's some debate, but there's a lot of other evidence as well that supports this idea. Looking at rhesus monkeys, Meany, Sumi, and Ziff, these are 3 great names in this area of the biological embedding of disadvantage, looked at, and I'll show you some detailed studies that I've done with Sumi, along with Gabriella Conti, that early peer rearing, a kind of form of maternal deprivation, actually affects gene expression. 22% of all the genes, 22%, close to a quarter of all the genes are affected by this biological embedding. So let me just show you how, so we looked at a particular set of genes associated with disease, immune resistance systems. So what we did is the following. We looked at a group of monkeys, and this is Sumi. These are Sumi's monkeys. These monkeys go back to Wisconsin back in the 1950s, some very famous studies that were made by a guy named Harry Harlow, and then his colony was eventually taken to Washington and put at NIH laboratory that's outside of Bethesda. So what they did is kids, the monkey children, are basically put in one of 3 rearing conditions. The natural condition, mother-reared, the peer-reared monkeys, where these monkeys raise each other, and then there's a surrogate peer-reared where you actually put in like a fake mother. You put in some kind of surrogate, but you don't really have a stimulation. Then they're actually removed, the last 2 are removed from the mothers at birth, they're raised into the nursery, and then they're put back into cages in various combinations. Okay. So without into all the details of this, these you can think of as different deprivation patterns. Now this is a heat map. And the only thing that's important to take out of this heat map is that what you can actually see is that there's a group of genes that are downregulated in the peer-reared monkeys. This is the group on the left, and they're upregulated. And when you actually start looking at where these genes, what these genes correspond to and what aspects of health. These are all aspects of health now in terms of immune response systems, antigen processing, and various other kinds of ways you can fight disease. You can literally see substantial differences. And those differences persist. So this starts to get embodied in the first few months of the rhesus monkey. Well, I'll show you. Here it is, the probability of developing an illness. So we actually follow it. So we can say, okay, that's very interesting. We can see very substantial differences in the genes. And Francis Champagne has done this. By the way, Francis Champagne in our laboratory at Columbia has actually shown that when you can deprive, the way that maternal deprivation for a rat is basically when a mother will not lick and groom her infant. That's absence of licking and grooming. That produces, licking and grooming reduces cortisol, eliminates stress, and the like. And what Meany and Ziff, and then the work and later work by Francis Champagne, who was actually working with Ziff and Meany in Montreal, shows is that you might be able to reverse the damage. You actually see an epigenetic link. You actually see the genes expressing themselves differently, but you might be able to reduce that in the sense of reversing it through some kind of pharmacological intervention. So you can actually make some injections, and at least in the case of the rat, you can actually reverse some of it. So what you actually find, though, for the monkey data I was showing you, is that you find much greater probability of developing illness. So if you're looking at the biological determinants of health, here is a contributor. It's non-trivial. We published this paper just a few months ago in the Proceedings of the National Academy and so forth. So that's part of it. So early life conditions are not the full story. resilience, recovery, and repair. And that's what we talked about already. Family, I think Lance talked about this, but let me just point out that what we actually find is that controlling for ability at the age schooling decisions are made, racial, ethnic, socioeconomic gaps in schooling actually reverse sign. And I guess at the risk of really blowing my time here, I'm going to show you some slides which I think are extremely important in this dimension. So again, I haven't gotten to the model yet, but let me, oh, okay, which slide is this? Yeah, here it is. Okay, this is from a talk I gave last May. So let me, yes, here we are. So this is what Bert was actually talking about in my paper, but this is something that I think is amazingly interesting. This has received a lot of attention. This goes back to some work by Derek Neal and Johnson and Fryer and others have shown similar evidence, so it's not, but this is actually showing the gaps in wages for blacks and for Hispanics against, say, whites. What the raw data is, what the raw data show, that's the raw gap for males and females, and then if you ability adjust. So ability adjustment plays a huge role. Not saying it eliminates discrimination, but you can see for Hispanic males, it actually leads to a slight premium, but there's no strong evidence of any difference. But you actually can switch from a negative to a positive, okay? It means putting in measures like AFQT with the effective non-cognitive traits removed and so forth.
I mean, like, can we engage that by saying that ability adjustment in a sense is just pushing the problem back in another layer?
Actually, that's a good question, and these actually take account of that consideration. Because what it's doing is it's adjusting for things like years of schooling and for measures of environment in the test score. Okay, so I completely agree that if ability itself only represents a consequence of expected discrimination, then for sure. No, and that one way that would show up would be through years of schooling. This is all eliminated, and that years of schooling at least are eliminated.
But somebody can say that's just structural racism.
What?
The fact that blacks and Hispanics have lower ability, right?
Yes, absolutely, and you can actually see, because when the measured ability gaps are real, when you just look at years of schooling attained. I mean, I'll show you towards the end of what the causal effect of an additional year of schooling is on measures of ability, both cognitive and non-cognitive. So if you have lesser attainment of education, you're going to show lesser measures of ability. Ability causes those, but it also causes. So you need a subtle method for looking at the reciprocal causation of those two.
What's the purpose of this exercise of adjusting?
The adjusting is to simply think, well, we looked at, we saw those ability gaps were there. So this is the way I would read this figure. If you go back, those ability gaps were there back at age 4, 5, and 6. So a lot of the factors that happened subsequent to that would not be really important in explaining these gaps. Okay, that's point one. So let's take anything up to age 3 and 4, okay? And we could adjust those scores even earlier on by things like family background and so forth. But put that to the side. What I'm suggesting, though, and in fact the real story is the next one, which is college entry proportions. So if you look, for example, I showed you the graph showing how important non-cognitive and cognitive abilities were. Here what I'm saying, look, if we look at this is in the late 90s, the data. And this is a paper with Cameron that we published some 11 years ago. If you look at the black-white gap in who goes to college, just entry now, and that's any kind of college, 2-year, 4-year college. What you actually see is a 12-point gap, lower for blacks, okay? And a 14-point gap for Hispanics, even lower. Okay, that's the raw data. If you adjust for ability, again, you can find that these gaps essentially are switched. And I think partly it's a consequence of affirmative action, many other strategies. But all I'm really trying to get at is those ability gaps open up early, and they play a huge role in explaining that. And the ability itself can be shaped, as I'll go through and explain.
I have a problem with this.
Okay.
I have a problem with this because in the first instance, when you showed the graph that went back to age 1, it seemed to suggest that there were no gaps, right?
Well, but remember, that's why wait, but the age 1 gap, that's why I didn't put it up initially, but that's a hugely controversial question as to whether or not there's a stable measure of IQ at that early an age. That's why I hesitate to do it. And I would just ask you to take a look at Lewis and McGurk in Science. 1972, where they actually go back and they say, look, we just don't think the Bailey score measure, those early measures are reliable or even that highly correlated with subsequent measures of IQ and achievement. But if you believe they are, then sure, it suggests very strong widening between 1 and 3. Yes, I completely agree with that.
The second problem with this, in a sense, like, this could be kind of like saying in a very backhanded way, like black circle for achieving in relative terms, even though in absolute terms they're underachieving, right? And somebody who wants to say that this shows that there's, in a sense, reverse racism could really make that point based on this graph.
Yes,
and so
that's true.
Like, I think in a sense.
But wait, let's be careful. I mean, I don't think this is such a politically charged graph in some sense. We do have affirmative action programs in place. I mean, it's well known, right? So all I'm saying is that in some sense, many people would say, well, after adjusting it would basically be 0. All I'm really trying to make with this is saying that those abilities are predictive. I can explain people from different socioeconomic statuses who are of the same racial and ethnic groups. I could do this. I realize this is a charged statement, and it's leading up to an argument where I think, A, those abilities matter, they're predictive. So the bottom row isn't so important as simply to say how powerful it is, not the absolute magnitude. And secondly, to say that many people would look at that, and if you were back to a genetic determinism, to say, okay, then by construction, these people never can succeed. But that's exactly what I'm trying to argue against in simply saying those capabilities can be changed. So I think, but it's important to recognize that those abilities are profoundly important in predicting who succeeds. And it wouldn't just necessarily be college, it would be white-collar occupation, it would be even measures of illness, it would be measures of likelihood to get diabetes and so forth. So I'll try to show.
I guess my only kind of like problem with this is I think that you can spin this left or you can spin this right. And so
That's almost true of anything, right?
No, I don't think so. That's my problem with this. I feel like this is, with this is more, if you take this particular kind of like adjustment is more kind of like imputation than like science. This specific like adjustment.
I think that's very unfair. It's a fact.
Yeah, I mean, these abilities get...
I'm not saying I'm right. I'm just saying that that's...
Remember that that a lot of these colleges have algorithms saying SAT has to be blah, blah, blah. And there's all this controversy about assignments and, you know, changing those standards. And so all I'm really making is saying that ability plays a huge role, like it or not. And those gaps are emerging at very early ages. And then we start thinking about how we can shape that ability. We can move beyond the genetic story, and we can actually say, look, there's a huge goal.
Your concern really is just why people need to look at what they're reading and not just take charts like this and say, oh, look, they're doing fine, they're doing better. You know what I'm saying? Like, it has to be presented.
Oh, but they're not doing fine. I mean, you can see the gap. No, I mean, the gap's there. It's gotten a little bit better, but it's not like this gap has been eliminated in the last.
That's not what I'm saying, but like people, especially thinking about the media, someone could go and say, well, if we look at what's really going on, because that's why we adjust things to see what's really going on. Like they could make an argument, but that's just faulty logic.
Yeah, but I also want to make the point. See, so again, if if Charles Murray were in the room, he would say, see, this is what I say, and it's this is the reservation story, that if that's the genetic determination story. But I think it is a fact. Pleasant or unpleasant, there are these gaps. What I'm really saying is a lot of what we think of. Remember that some of these measures, these measures are including non-cognitive skills. So that these scores are capturing lots of ideas. So I'm not suggesting that this is innate and necessarily can't be dealt with in any kind of social policy. In fact, just the opposite. But it is a fact, right? It is a fact. But yes, go ahead.
I guess what I want to say is similar to the point you just made, but we already saw that AFQT is not, it's somewhat predictive of college entry, but there's a lot of noise in there. You have to think about the covariance structure of, the particular skills you're measuring with this score and all the other non-cognitive abilities or, cognitive abilities that you don't measure in the test that fit into this figure. That's the point of doing the estimating, this structural approach is to try and understand, well, maybe what you're looking at here is a particular covariance structure that's produced from the different, social outcomes that are an average black male or female with high ability faces compared to an average white male or female with high ability.
Right, and these are very, very crude adjustments. When you put in things like non-cognitive skills, you're going to get a slightly different story. Those will help explain, actually weaken the gap, the explanation here. You'll go down from 0.16 and so forth and so on. But the fact of the matter is that the general point I'm trying to make is that, so, you know, this is probably a tactical, well, it's useful. It kind of gets the conversation going. But what it really, this shouldn't end the conversation. There should be a large vector of these traits that are in there. And we understand exactly that we want to look at the components of the traits and how they evolve through investment and through environment. And yes, there will be a genetic basis for some of this, but there will also be a powerful environmental component. And that's really what I'm trying to lead up to. So I agree, I think, with what you're saying. This is, let me get out of that. So that was kind of deliberate, but I think useful, because it is suggesting, amplifying the theme before, that these are very important determinants. Oh my God, did I get out of this graph? Oh, this is crazy. This is not good. Okay, well, I can scan this quickly. Where did I end up here? Okay, so we went through, we're going a little slowly here, but it's useful. So what I'm really okay, here's the genetic basis. Now, in terms of the, this is the monkey data I told you about, and this is the consequence. Early life conditions aren't the full story. There's resilience, recovery, and repair, and constraints matter. So, and this is what this bullet is where I stopped and went off on this topic. Controlling for ability, at the age schooling decisions are made, you actually reverse the sign. I agree. See, that's the whole literature about saying, if we control for measures that are already contaminated by discrimination or by expectations, we're not explaining anything. They're just captured. There's an attempt made in these graphs that I just gave you for at least some of the crude components of what would be things like years of schooling and certain environmental differences. And it's certainly still true that you are finding, A, that ability is important, and it's extremely important. And to me, that figure, coupled with the figure that the ability gaps are opening up early, is very powerful. It still doesn't answer the question about genes versus environment, not yet, but or the early years versus the later years. Okay, so enriched early environments compensate in part, and this is the peri-preschool study that I worked on with Seung. And basically, this is the finding that I mentioned before. This is the treatment group and this is the control group. These kids entered at age 3. Their IQs by construction were supposed to be subnormal. That's the way the state of Michigan funded the study, for subnormal IQ children. And so what you got was a huge surge when people were in the program at age 4 and 5. IQ for the treatment group went up. IQ for the control group also went up, but not with the same surge. At age 10, they basically had the same IQ. Treatment and control had the same effect, very similar to what was found in Head Start. Yet, when you look at this program, and we follow these people to age 40, these people are randomly assigned to these 2 treatment streams, and what we find is there's a statistically significant effect of 7 to 10% for both boys and for girls, separately. And this is accounting for costs of social cost of taxation, all of the deadweight losses associated with a proper cost-benefit analysis, and that's a very high economic rate of return. And what's the mechanism? So this is the causal evidence that I was trying to say. We actually measure the personal behavior index by treatment group. So we actually can see the treatment group has, if you look at things like personal behavior, these non-cognitive traits, the treatment group distribution is shifted to the right. That's the more favorable outcome. The control group here. So we can actually see in this component the socio-emotional index, again, ability to get along with others, some measures of sociability. And when you look at the treatment effects, and you ask how much of the treatment effect is explained, interestingly enough, by the way, just like I was showing you that the achievement test scores were largely a combination, were just a combination of both IQ and non-cognitive traits, acquired knowledge, that what you find is even though the IQ is no higher for these groups, the achievement test scores are higher for the treatment than the controls. Okay? So here's a case. It partly answers Lonus's question here, and that is, look, here we are. These groups were randomly assigned. The genetic differences are really random. It's large enough we can start averaging out over these groups, I think. And what we find is substantial differences when I look at the 7 to 10%. Lasting mechanisms, lasting outcomes, and the mechanism is largely these non-cognitive traits. And so this is just a percentage decomposition of the total treatment effect. Let me also show you, I'm never going to get to the model, but here, the causal effects of education on capabilities. So this is one piece of the causal study. The GED study I mentioned Thursday night is actually, I would argue, a version of a causal story in the sense we use what is called in epidemiology Koch postulates, standardizing for a variety of outcomes and finding substantial differences between those with high cognitive and those with low non-cognitive skills. But putting that to the side, if we look at observational data, we actually find this kind of effect here. We can actually say, what's the effect of an additional year of schooling on completing the test? Now, how can I do this? I mean, there's obviously circularity. You're going to jump on me for the same reason. No, it's correct. You should jump on me. But this, I would argue, again, this graph controls for it. How does this control for it? Two ways. One is through a very elaborate structural model, but a second is through a very simple approach, which actually leads to virtually the same conclusions when it produces the same parameters. Namely, we actually have data on children who, these are longitudinal data. We follow them, they're now in their 40s, these kids. We can tell who goes to college and who doesn't go to college, okay? So we actually know, we can condition on people who go to college and use that as at least a conditioning measure for what ability is. Then we can ask, what is the schooling that they have at the time they're interviewed? There are different ages when they're interviewed. And that's more or less randomly assigned. Some are 14, some are 15, some are 16. We can all follow them at the time they're 27 and 30. We condition on that, and that's more or less the way these plots are generated. There's that, and then there's a more sophisticated method. Fortunately, the two line up. So not surprisingly, additional years of school produce more knowledge. You hope so, anyway. Paragraph comprehension and so forth, math knowledge, coding speed, which Carmeet Siegel actually is claiming to be really more a measure of non-cognitive traits, conscientiousness, your ability to kind of focus and do tasks. But if you look at measures like Rotter locus of control and the Rosenberg self-esteem scale, you'll see additional years of schooling promote those as well. So that's a finding. Later remediation is costly and often ineffective. And this is something now where you could have a whole course, or at least a whole lecture or two. If you look at the evaluations of most active labor market programs, if you look at most class size reductions, especially in the later years, adult literacy programs, public job training programs, tuition reduction policy, you'll find, take for example, classroom size. There was a study done by Card and Kruger some 15, 20 years ago suggesting reduced classroom size produced higher earnings. And there's no question that it does. A lot of evidence on that effect. However, to reduce classroom size, you have to hire more teachers, build more schools. When you do the cost-benefit analysis, it turned out that the rate of return on class size reduction is negative, okay? If you do the same thing for public job training programs, you know, some job search assistance programs get a rate of return that justifies their support, very modest returns. But tuition reduction, adult literacy, and a variety of these active labor market programs typically don't have, they're targeted, remember, typically, a lot of these programs anyway, towards less advantaged people in the adolescent years, and they generally have very low rates of return. That's not to say you can't do better, but they have been relatively less effective. Okay, so what's the pattern? Returns on later life programs are higher for the more able, which I showed you, lower returns for the less able in the adolescent years. Motivational programs seem to work, and so forth. Okay, so the question is posed here. Now, it's 5:45. How much more time? 15 more minutes?
No, just sharing a second. I'm serious.
10 minutes? Okay, fine. He's ready chairing the session?
Yes.
That's ruthless. Okay. Well, I have about another 150 slides, so I'll try to, but let me sketch a model. Let me sketch a very simple model. First of all, it's been referred to several times, this paper by Becker and Tome. It's an early paper that loosely guides the recent research. It looks at parental preferences, altruism, intergenerational credit markets and bequests, parental investment in child skills, and some actual measures of genetic mechanism. I have some notes on that which I posted. I don't think I'm going to get through this. More recent research here, surely the chair will want me to acknowledge his work, so I'll give me another half hour. Bernal and Keene, Todd and Wolpen, Del Boca, Flynn and Wiswall, Melissa Tartari, Gabriella Conti, Akibayashi, Bruce Weinberg, Marco Coscanati, Cowcut, and Lochner. So what are the ideas here is multiple stages of childhood, which moves beyond the single period model that dominated the early literature, moves beyond schooling as the main investment, schooling, training, preschool, and early investments, recognizes the modern literature on the biology and psychology of skill formation, multiple capabilities. In the more recent work, in particular the paper by Flynn and co-authors, multiple children, which is an important extension. Interactions between child and parents, and looking at budget constraints. So this is the model, which I already went through. Just to review that, and let me sketch out, I don't know why I put this here, but I did. So this we've already covered. Except to say one thing, that in the literature, for example, in criminology, there's a book by Daniel Nagin. And Nagin and Tremblay have a whole set of models, which are basically called ontogenic models, where basically the notion is that you have a fixed trajectory, that people start with certain types. They're born like certain types. Investment doesn't play a very big role, and the initial conditions fully determine it. So it's a little bit like sending an ICBM to Russia. You know, you basically, once you launch it, there's nothing much you can do. And it's similar in some sense to what Keene and Wolpen do, and so forth. More general models allow for adaptive processes and feedback. Okay, so let me lay out the essence of the framework. I'm not going to be able to go through it in detail. I'm going to give you what I think is going to be 3 different environments in terms of constraints. Actually 3 constraints, although I mentioned 2. First of all, there's the constraint that what's sometimes called the accident of birth. Children are born into certain environments and they have no choice. I mean, there are models, right? Your colleague, right, Sheshadri, has a model where basically...
He actually is my friend.
Okay, well, no. Yeah, no, but Sheshadri's model is basically with Greenwood and is it Yorikoglu or just those 2? I've forgotten. But basically it's a complete model where you can actually, children can buy insurance against bad parents. So they're fully insured. So the fetus is out there in a market, complete claims market, and insuring against a bad kid, a bad parent. That's a tough, that's a constraint I'm not going to worry too much about. But I am going to face about, what's that?
That gives theory a bad name.
No, it's a benchmark. It's okay. I like the idea of the homunculus negotiating for, signing a contract, getting insurance against having a bad mother. No, it's a useful thought exercise. And maybe it'll happen someday. Who knows? But so that's a market to complete, right? But anyway, so parents face different constraints. The inability of the family to borrow against the future income of the child, and the inability of the parent to borrow against their own income. Those are 2 separate constraints. The first constraint, I here, is the one that's been somewhat looked at in the literature, and the second is not looked at much at all, partly because we only have 1 period, typically, in the life cycle of the child. Now with multi-periods, you can get at some interesting phenomena. So let me just sketch that model. So let me lay out the rudiments of the model quickly, I guess. So let there be 2 parental investment, I1 and I2. That's the same notation I used. 2 periods of childhood, 2 periods of adulthood, and so forth. Okay, so we can solve the model recursively. And we can solve back and say in the third period, when the child's an adult, given its initial conditions, given the investment, I'm going to abstract from the other determinants of the stock. Investments are determined by parents. There's the initial condition of the child. In this very simple model, that basically is going to be the production function when you solve out the recursive formulation. Look at. Now the key idea intuitively though, and this is why I'm just going to make some very basic points and maybe sketch a more general version. The key idea intuitively is the following. When is the two-period model a good, one-period model a good description of the two-period model? That's when investment's perfect substitutes. The timing is irrelevant, right? And so in the particular case, which I think has implicitly dominated the literature, perfect substitutes, where gamma, say, would actually equal to a half, Becker and Tomes, where basically investment in one period, investment in the second period of childhood are basically equally productive. You could even, in the perfect substitutes case, have that investments would be more productive in one period or the other. That would be gamma. Okay. The other case is the Leontief case, perfect complements. The perfect complements case is basically saying if you don't get it early, you don't get it later. I mean, there's no point in investing later if you don't get it earlier. It's the minimum of the two. So that's the notion of a left shoe and right shoe. You need a left shoe to walk, but you need a right shoe to walk. So it's really suggesting that basically complementarity has a dual face. It's essential to invest early because later compensation would be very difficult. It's also essential to invest late to harvest the results of early investment. So that's really an empirical question. And obviously the more, that sort of cries out this generalized mean, this CES kind of technology would be the natural to say, well, what is the elasticity of substitution between early and late? So that's an empirical matter. And I want to think of gamma here as basically a skill multiplier. You can show when you solve out the reduced form how gamma is related to the productivity and cross-productivity of skills. But here I'm going to take only one dimension of skill. Okay. So basically sigma, which is obviously the elasticity of substitution, 1 over 1 minus phi, just shows you how easy it is to substitute. So we could have perfect substitutes, or we could have perfect complements, or something in between. And let me, so this technology, simple as it is, helps to explain why returns to education might be very high in the early years and very low in the later years. If you started with severe disadvantage, and if you were a perfect complement, there was nothing you could do. That's really a kind of a sense that it's too late to do much. On the other hand, it would also suggest that if I gave you an initial base and then followed it up, the returns could be extremely high. Okay, so you know, just this is making just the logical case I made before. So let me just go forward and say, okay, let's take the general case. And let's suppose we write down preferences. They're in the background here, but let me just sketch what a first order condition would be. So with very general preferences, a parental altruism for child outcomes, you can get that the ratio of investment in period 1 to in period 2 would depend on that share parameter on investment in period 1, the interest rate, which I will soon set to 0, and the elasticity of substitution. Okay, so that's the key notion here. So what you get is something quite interesting in various cases. So as I said, the literature is basically, a lot of it was assuming elasticity of substitution about 1. So you could get like a right angle graph here. The perfect complements case is really with the share parameters equal, would be 1 for 1 equal. And various other cases, like the Cobb-Douglas, would be this red line. And then as I move to higher and higher levels I could get more and more perfect substitution, more and more complementarity would be like the green line. So that's giving you an idea that for different levels of gamma, which would be the skill multiplier, how the model would suggest, should I invest more relatively early or relatively late? So anything above 1 would favor investment in early childhood relative to later childhood. Because and the higher this gamma, it's the higher the initial investment productivity is, which would operate through the self-productivity of that process. So let me just, I'm not going to have any time here. So the first case where parents can't borrow against future income of children, you can show that that essentially is a model in which the children's income comes much later. So the kid could be a genius. Could you have a future Bill Gates here, and you know it yourself, but you can't reveal that to the market. What you can show, though, is that it reduces I1 and I2 but by a common proportion. It's not going to do anything in terms of the timing of early versus late investment. However, if parents can't borrow against their own future income, and you basically have the typical pattern of a rising income stream with the child, that what you're going to find is, yes, like before, it reduces I1 and I2, but what it does do is it reduces I1 relative to I2 in a fashion that's consistent with the notion that early income of the parent could have a very high return in boosting I1. But it can be undone. So depending on how altruistic the parents are and how patient they are in terms of their consumption. I'll sketch out very quickly what's going on here. Let me skip just to an example here. I'm not going to get to all this stuff here. This is too bad. Okay, here. This is the model that I have in mind. So this is a more general version. Parents live 2 T years, T years of childhood, household as a parent and child. This is somewhat more formal. The wage, the interest rate. On reaching adulthood, parents receive a bequest B, and there's a state variable for the parent. Their parental skills, H, which are the parental financial resources, B, and the initial skill level of the child. So let me just lay out the budget constraint, maybe. So what's the budget constraint in this first model? So C1 is the consumption of the parents. I1 is the investment they make. C2 is the investment in the second period. This is when the kid's at home. And then basically B prime is the bequest they're going to leave to their kid. Okay? So that's all what the parents are doing. This is their earnings. This is their human capital, right? WH is their earnings. That's the wage rate. This is the wage rate in the second period. And this is the bequest that they get from their parents. So that's basically then the intertemporal constraint. No one period constraints. You can borrow freely about your income, okay? Beta is a discount factor, and we can write down a model in which you have 2 periods. The parents only care about the well-being of the adult child. They don't care. The little kid can be screaming and locked in a cave or whatever. It's just adult consumption, just a stylized model. Beta is a time preference parameter. Delta is a degree of altruism. And the parents are basically expecting out this is a recursive formulation for the problem of the parent. So take the special case that I started with a minute ago. These are the 2 technologies, and this is repeating everything I said. So I extracted the early part from this, but let me just get to the general case, which I just showed you, and let me consider alternative market environments. So this is what would happen without any restrictions on constraints, okay? So this is where I left you a minute ago. But now let me consider a complete market model. Now in a complete market model, optimal investments do not depend on parental permanent shocks to wages. Okay? So basically, children, you could borrow against future income, but you'll notice something, that even when you have perfect credit markets, parental investments will depend on parental skills. Why? Because parental skills affect the returns to investment. Right? So even if you can borrow, so the parameters, if you actually have a more educated mother or less educated mother, that's not going to be fully insured against. Because that's where you can't buy your parent. Unless the kid can go out and finance somehow an alternative parent, which I'm abstracting from. So this generalizes Becker and Tomes, shows the fundamental role of parental influence. So if parents can't borrow against future earnings of their children, a second constraint is going to be the non-negativity. They can't leave a negative bequest. You know, if you have Bill Gates as your kid, you might want to leave him a nice $1 billion negative bequest and have a very good life as a parent. But you can't. So you get if you have this binding constraint, then you can basically show it gets lower investment in each period, but doesn't affect the ratio of investments. Okay, that's fairly straightforward. The more interesting case is where parents themselves face lifetime liquidity constraints. I'll quit very shortly here. They face lifetime liquidity constraints, and now parents face a sequence of constraints in their lifetime, right? Because they can't borrow even against their own income. And the typical profile is a rising income profile for the child, right? And so you get the first period constraint, where that's parental savings. But parental savings can't go negative. And there could be actual growth rate. And here in the second period, this is showing that the wage is higher. So it's one period here, its wage is going to be W here, and it's W1 plus alpha in the second period. And you can't, now you have two kinds of constraints. You can't leave negative bequests, and you can't even borrow against your own income. You have to save. You can't borrow against your future income. So if you write out the first order condition, you get something that looks interesting. And so suppose that I just write the standard lifetime utility. This is a very stylized model, and there's a lot more evidence on this question. A lot richer evidence than this. But let me just start with this. So what you get is that first, if you recognize what I've written here, this is basically the ratio of investment in the first period to investment in the second period. This is the same expression that I had before, right? Same expression. But now, this expression, which is basically consumption in period 1 over consumption in period 2, that is basically going to be constrained so that C2 is bigger than C1. You're really writing against the constraint. That's the constrained case. And that's going to depend on the importance of this. Modifying early investment is going to depend on the relative magnitude of lambda, which is this intertemporal substitution parameter in consumption, and phi, which is this intertemporal substitution parameter in investment. So you have an investment side and you have a consumption side. And so you can easily see that depending on the strength of this, I mean, this thing could actually be, I mean, suppose that it turned out that lambda was basically, well, here, let me show you what the actual magnitudes are instead of guessing. So there's a tug of war between lambda and phi, as you can see. So with sufficiently high lambda, we say, well, lambda is equal to 1, that term is negligible. It goes back to 1, right? Just for values of phi, unless it's indeterminate. But let me just suppose that phi is not 1. And so what you're getting then is basically that the ratio is going to be independent. And then we're back again. So what's going on is that with sufficiently high intertemporal, you know, the fact that you have some altruism sitting there, but you also are willing to postpone your own consumption. If parents are willing to do that, then it's not going to worry. So they don't mind starving themselves to compensate for the kid. That's going to be subject to some corner conditions. Empirically, if you look at the evidence, so Cunha and Suzanne Schanak and I actually estimate some of these parameters, actually in a more general model. And Attanasio and Martin Browning in an older paper have an estimate of what lambda is. And so what you can actually see is that this ratio is, you know, that this issue is basically this ratio here, this exponent up here, is in the vicinity of around 1. But not, it's 1, not 0. So there really is an effect where the binding credit constraint can matter. And so for constrained households, as Lochner has shown, as several pieces of work have shown, early family environments, early family income can really influence the investment of the child. Let me go back and stop. I better stop. I realize you won't stop me, Seong, but I'll stop myself. Let me just make a few other remarks. There are a bunch of estimates of this, and I'm not going to be able to show you these, I guess, here. But I do, let me, one or two more just observations based on this. So Cunha and I, let me just talk about the issues, because I'm nowhere near, so these are the alternative market environments. In a series of papers with Flavio Cunha and Schanak and Cunha, we actually estimate this technology. Those thetas become factors. And those factors don't have to be linear factors. We actually have models for non-parametric, non-linear, non-normal factors. So you can think of having a bunch of measurements out there. In the most recent paper, we have like 130 measurements, and we try to extract the dimension of the number of factors. So we're estimating a dynamic state space model, and we can identify the technology non-parametrically. So even though I've given you, and it's a vector of capabilities. It's not just one. The simple example gives you intuition, but it doesn't give you much guidance to thinking. But there are a huge number of challenges, and just to state them quickly, there's a multiplicity of measured inputs and measured outputs. There's measurement error in inputs and outputs. There's endogeneity of investments. You want to look at that for causality. There are a bunch of emitted inputs. And in a series of papers, we tackle these questions. And they're posted on the reading list. And I'm happy to go through those, but later. And that's probably another another week or so. And there's another question here too, which actually shows up a lot in the economics of education. Namely, there's a lot of reliance on what are called value-added measures of test scores and so forth. You know, value-added measurements of schooling. Schooling adds. Output as measured by test scores is meaningless. A test score is just a scale, an arbitrary scale. Any monotonic transformation of a test score is a test score, so you need to anchor it, and we do. So we can actually non-parametrically anchor it. How do we anchor it? In how the non-cognitive and cognitive and health abilities actually affect the structure of outcomes. So it turns out you can recursively anchor it and get something that's invariant to monotonic transformations of the test score. So what do we find when we estimate the model? Self-predictivity becomes stronger as children become older, harder to change. Complementarity between cognitive skills and investment becomes stronger as children become older. And the elasticity of substitution for cognition is smaller. So the possibility of remediating later in life is weakened on the cognitive dimension. What we also find, the elasticity of substitution is about 0.3. Complementarity between non-cognitive and investment skills becomes slightly weaker, okay, as children get older. And it's actually easier at later stages to remediate through non-cognitive mechanisms. So the cognitive mechanism is much harder. The non-cognitive measurement are somewhat easier. So there's an econometric counterpart to all these assertions. Now going back to the graph that I put up on Thursday night, we'd say how much of the variation in educational attainment is explained by cognitive and non-cognitive abilities? It's only a third. There's still a lot of measurement error, and there's still a lot that's unexplained. It's better than the 7% for IQ for earnings, but it's still quite substantial less than the whole story. So it measures the cognitive and non-cognitive skills are powerful, and you can actually boost these non-cognitive skills. And now let me just put this to rest here with one last remark about how we can integrate family intervention studies with family influence studies. So far, I've looked only at family models, and I've shown you a bunch of interventions like Perry. What I'm suggesting, though, is that we can essentially allow, through the technology of skill formation, to integrate studies of both family influence and interventions through their effects on theta. So I gave you an example of that earlier, but just write down the following technology. We can imagine any technology is going to be the outer envelope of a bunch of underlying technologies. We have a government technology that can depend on the capabilities of the child, what the parents have, and generally most of the evidence, not all of it, has actually found that there's complementarity. So that answers a question quickly in the literature that providing better opportunities actually evokes more parental effort. That's the investment of the government, the investment of the family, and the investment of the parent. There's also a family technology, and both technologies can be in place simultaneously. So you could have various special cases. Here's one specification. You could basically say, oh, I'm going to add the government technology and to the private technology. That would be one specification. And the family's choosing the least cost technology. And families may have multiple as an alternative private technologies. And some of the work by Seong and so forth, looking at various ways that you can put these studies together. And so what we can actually do, and what we actually do, is say how much does something like Perry Preschool or ABC change the capabilities of the children? So now we can say, what is Perry like in terms of changing the family environment? We could change family environments. We could also change through government centers. And so we want to sort out how these inputs affect the underlying cognitive and non-cognitive capabilities. So through this vehicle, we can put all these studies together. So treatment effects now can be thought of as operating through changing these capabilities. Those capabilities produce outcomes. Okay, so I'm going to leave this to James Best. There's a very provocative study. Again, I keep forgetting the guy's name, Steve's favorite economist. Brian Kaplan, that's it. Ryan Kaplan or Brian? Brian. Okay, Brian. There's a book by Judith Rich Harris, Turkheimer, and others looking at this question. And Harris has made the claim that parenting doesn't matter. Parents may matter in the sense of their endowments, going through genes, and so forth. And what I've just shown you is that experimental interventions to supplement family life can boost theta. So the idea that parents don't really matter is kind of irrelevant. I'll just show you some graphs. These are disparities in education, British data. We actually look at log hourly wages, look at health. This is just the elementary, this is basically, do you have elementary schooling? Do you get minimum compulsory schooling or not? So if you're more likely to be, so there's a difference by males and females, who smokes and so forth. This is the educational gradient. This is like 20% less likely to be arrested if you go above the minimum school leaving age, less smoking, less depression, less health problems, less obesity, less eating of fatty and fried foods, more exercise, more fruit, more employment, more hourly wages. The question is what's causal? And without, this is kind of a standard diagram, so I will spare you that. But what we actually conclude by using a variety of methods, using the state-based methodology, is that when we decompose the return to schooling, this is now compulsory schooling, the blue part is the same, the graph's the same by height, the bars are the same height, but the red part is actually due to factors that were present by the time the kids were entering adolescence, say at age 10, and the blue part is the causal part. And so for employment, a huge causal effect, big causal effect on smoking, reducing smoking, depression, but a huge early life effect as well. And so that suggests, that's very suggestive about these things. And you can actually compute distributional treatment effects. So with smoking, not surprisingly, some fraction of kids actually start smoking when they go to college. Some fraction of kids stop smoking. The average treatment effect is, in this case here, it's idealized, or only it's a binary, do you smoke or not? It's only three values can be realized. And so these are people who don't change status. These are people who actually start smoking. These are people who actually stop smoking. And you can see what the distribution of treatment effects is. And that's a fruit of the state-based model, and shows you who benefits. And I think at that point, I should stop. There's a dynamic sequential model of schooling that I could talk about, but I won't. So we can then move on to genetics. Is that the plan? What's that? Oh.